Olá pessoal, tudo bom? Sejam bem-vindos a mais um vídeo aqui do canal. Hoje um vídeo um pouco diferente, não é uma videoaula, né? Mas sim é uma apresentação que foi realizada num evento. Especificamente eu estou falando do Encontro de Outono da Sociedade Brasileira de Física. Na última segunda-feira, dia 21 de junho de 2021, começou a edição desse ano, desse que é o maior evento de física que acontece no Brasil. No ano passado, na última edição, eu apresentei nesse evento um, um trabalho que foi realizado no laboratório de física da Universidade do Amapá, onde eu trabalho, certo? E esse ano eu trouxe uma outra apresentação que está relacionada com o que eu estou fazendo atualmente no doutorado. Eu comecei o doutorado esse ano e eu estou investigando alguns minerais por algumas técnicas poderosas aí de caracterização, né, que é difração de raio-x, espectroscopia Raman e microsonda eletrônica. Então a apresentação teve esse título, né, que foi Investigações sobre substituições químicas em minerais do supergrupo do pirocloro. Essa foi a primeira apresentação que eu faço em inglês num evento, né, desse porte. Eu tinha feito aqui no canal há pouco tempo atrás um vídeo onde eu fiz uma apresentação de teste em inglês, mas esse foi o primeiro que foi valendo, né? Que vai gerar um certificado aí e vai entrar para o Lattes depois, certo? No mês de agosto eu vou fazer uma outra apresentação que é no Encontro da União Internacional de Cristalografia. Eu prometo que eu vou trazer também o vídeo aqui para vocês assim que sair, tá certo? Bem, eu treinei para essa apresentação, eu preparei um roteiro. Eu acredito que eu fui até bem. Tipo, na minha avaliação, eu cometi poucos erros de pronúncia, né? Eu assisti o vídeo algumas vezes, mas sempre tem uma gaguejada aqui e ali, uma pronúncia que não saiu muito legal, alguma coisinha ou outra, um errinho, coisas que a gente vai aperfeiçoando, né? Então, vamos ver como é que ficou. Eu vou colocar o vídeo aqui para vocês, tá? E aí depois no final a gente comenta mais um pouco. Vamos lá.
Okay, so now we can see it. Please move the mouse. Okay, it's good. So the next presentation is the investigation on chemical substitution in Pyrochlore-Supergroup minerals, and
Okay,
Gerson Lopez. So you have around 12 minutes for a
okay.
presentation and then 3 minutes for questions.
I'm having
Okay?
some trouble. I'm having some trouble to put in the presentation mode. So I think now it's okay.
Okay, no, it's okay. It's okay.
So, hello everyone. My name is Gerson Anderson. I am a PhD student at São Carlos Institute of Physics, and my advisor is Dr. Marcelo Andrade. Today I will talk about my investigations on chemical substitutions that may occur in Pyrochlore-Supergroup minerals. The Pyrochlore-Supergroup minerals is a set of natural compounds which have the general formula A2B2 X6 and Y, okay, as you can see here, where A and B represent cationic sites and X and Y represent anionic sites. Currently, there are 7 groups within the supergroup, and they are defined by the dominant valence of the ion at the B site. We have tungsten for osmolalite group, niobium for pyrochlore group, tantalum for microlith group, antimony for homate group, titanium for beta fit group, aluminum for halstonite group, and finally magnesium to kieselite group. They are all cubic oxides that usually crystallize in space groups Fd-3m and P432 group. All of them are similar in structure, and this is called the pyrochlore structure. Although I am talking about natural compounds in this presentation, they are all natural, but if we consider also the synthetic compounds, there are more than 300 different substances with different properties that have this kind of structure, and they receive in general the name pyrochlores. This is because this is a chemical versatile structure that allows different elements to take part in it through the mechanism of the chemical substitution, and that's why this study is important. The nomenclature of the Pyrochlore-Supergroup mineral species obey a scheme published by Atencio et al. In 2010. The names are formed by two prefixes and the name of the group, where the first prefix refers to the dominant ion at the Y site, and the second prefix refers to the dominant ion at A site. For example, we have this first formula here, where OH is dominant in the Y site, so the first prefix is hydroxy. We also have calcium as dominant at A site, so the second prefix is calcium, and this is a microlith because tantalum is dominant at the B site. Another example, the second one here, we have fluor dominant at Y site, and calcium as dominant is in the A site, so the first prefix is fluor and the second is calcium, and this is a romeate because antimony is dominant in the B site. Pay attention to the fact that if I substitute the dominant ion in each position, I have a different compound. So the correct determination of the chemical formula is very important in the study of the pyrochlores. And this is only possible with a combination of different powerful techniques as electron probe microanalysis, single crystal X-ray diffraction, and Raman spectroscopy. I used these three techniques to characterize three different samples chemically and structurally from two different occurrences. But in this presentation, I will emphasize the chemical composition data. The first sample came from the locality of Kalugari Hill in Macedonia, and I found that it was a fluor-calcium romate. The other two samples came from Praborna mine, and I found they are both hydroxycalcium romate. All the samples are similar in structure. Their crystal structure is showed in this figure here. As I said, I will skip for now the crystallography detail to concentrate in the chemical substitution discussion. The formulas I showed you before were ideal formulas, only with the dominant ion in each site. But here are the empirical formulas with all the substituents. And each site is highlighted in different colors: blue to the A site, green to the B site, black the X site, and red to the Y site. As you can see, sample 1 has fluor as dominant in the Y site, and samples 2 and 3 have OH as dominant in the Y site. All of them have calcium as dominant at A site and antimony as dominant in the B site. So the names fluor-calcium romate for sample 1 and hydroxycalcium romate for samples 2 and 3. Analyzing the possible substitutions, we can foresee the new mineral species that could be discovered. And if we could, for example, synthesize a similar structure but with different ions as dominant in each site, we give rise to a different compound with different properties. Chemical substitutions occur due to pyrogenesis conditions, through chemical reactions between the considered mineral species and the associate minerals present in the environment. Pyrogenesis, in turn, is a process of formation of a mineral from its precursors due to weathering and environmental conditions. And the relevant physical-chemical conditions for pyrogenesis is mainly temperature and pressure, but also others like humidity and pH. But it's also necessary to exist chemical compatibility between the elements of the mineral we are considering and those of the associate minerals. And the factors we may consider for this are valency, ionic radii, and affinity. So to start the discussion on the first sample from Calugary Hill, here I bring again the formula, the empirical formula, and here is a list of the associate minerals. And in the colors, we can see the elements, the valences of the ions which are present in our formula. But I highlighted some possible others. For example, lead, magnesium, and iron. Just for comparison, I put here two different pyrochlore species. Both of them are approved mineral species. The first one, oxyplumberomate, it shows that lead is an important element that may be present as a substitute. And fluoronatrocouselite have, for example, sodium as dominant in the A site and magnesium as dominant in the B site. So they are possible substituents in our structure. Continuing the discussion, here I bring again the other two formulas, empiric formulas, and the list of associate minerals. Again, we have in the colors the elements which are present in our structure, but I highlight possible others. And for comparison, I put here two other already approved mineral species, for example, hydroxyferroromate and hydrocano-ralstonite. The prefix cano refers to I don't know how to say this.
2 minutes, yes.
But it's when we have
vacancy.
Vacancy. Okay, yeah, vacancy, unoccupied site. Okay, thank you. So in the first occurrence, Calugary Hill, we have two species already reported from the Pyrochlore-Supergroup minerals, hydroxycalciuromate, published by Ermolaeva in 2017, and flucalciuromate in this work. And by analysis, I list these three others, for instance, hydroxyplumberomate, fluorplumberomate, and fluorcalciocouselite. These are possible new minerals to be discovered or synthesized. And in the second occurrence, Praborna mine in Italy, We have 2 species from the Pyrochlore-Supergroup already published. The first one is fluorocalcium-rhomeate by Brugger et al. And hydroxycalcium-rhomeate in this work. And here at the right, we have a list of the possible minerals to be discovered or synthesized. The other problem is that the scheme of nomenclature in the Pyrochlore-Supergroup doesn't consider that different valences for the same element may be dominant in the B site, for example. No? And this is undistinguishable by X-ray diffraction because they have similar scattering factors, but we can use, I intend to use in my doctorate course the technique of X-shafts in synchrotron to differentiate them using the absorption edge, the X-ray absorption edge. So the conclusion, I made the complete description of new occurrences for the minerals fluorocalcium-rhomeate and hydroxycalcium-rhomeate. We are studying the possibility to forecast possible new minerals to be discovered, and we are searching for a solution to the problem of the valences by X-shafts. Here are some of the main references and the acknowledgements. So, thank you very much. If you have some questions, I can answer them.
Okay, Gerson. Thank you for your presentation, and we have time for some questions. If someone wants to make a question. Gerson, I make one. Are there some theoretical results for this calculations for this kind of minerals? Do you know?
Yeah, we have some theoretical calculations for the structure and some properties, some mechanical properties, some electronic properties, and there are also some pyrochlore species which have magnetic properties. Some of them present magnetic frustration. So there are many theoretical works that try to predict some of properties related to these structures. For example, we can calculate powder diffraction, Raman spectrum, and another possibilities.
Okay, Gerson. Thank you once again. So we can go to the next.
Thank you.
Pois é, galera, essa aí foi a apresentação, vocês viram como foi, né? O evento está acontecendo agora de forma remota, né, em virtude da pandemia. A gente vai se adaptando a esse tipo de apresentação, não é uma coisa muito comum para a gente que é da área acadêmica, participa de congresso. No caso, eu que sou professor, eu sou acostumado a estar lá em pé, na frente do slide, com a canetinha, o pointer, né? E agora a gente tem que se adaptar a esse... Você não vê o seu público, né? Então... Mas foi bem interessante. O vídeo ficou um pouquinho baixo, o áudio, na minha opinião, mas eu acredito que foi alguma configuração aí do Zoom, que foi o aplicativo que a gente usou para fazer a chamada, né, onde aconteceram as apresentações. Teve uma pergunta ao final, eu gostei da pergunta, espero ter respondido satisfatoriamente lá para o professor que perguntou. E agora eu espero escutar aí os comentários de vocês, tá? Bem, Eu prometo trazer também depois essa mesma apresentação aqui em português, né, para aqueles que ficaram curiosos aí sobre o que eu estou falando, né? Não sei se todo mundo está familiarizado com o idioma em inglês, tá bom? E eu vou colocar um link aqui também para vocês encontrarem esse trabalho, né? De repente alguém está interessado em pegar aí o PDF da pesquisa ou conversar um pouco sobre o que eu venho fazendo no doutorado, o link vai ficar aqui na descrição, beleza? Então é isso, galera. Se você não deu o like no início do vídeo, dá um like agora, se inscreve no canal se você ainda não está inscrito e compartilha aí com seus amigos, compartilha nas redes sociais. Vamos divulgar aí um pouco do conhecimento da ciência também no YouTube, beleza? Valeu, pessoal. Muito obrigado. Até logo.